Imagine this. Two identical twins. One stays on Earth. The other blasts into space and orbits our planet for 6 months aboard the International Space Station. When the astronaut returns home, something extraordinary has happened. Something that sounds like science fiction but is absolutely, undeniably real. The twin who went to space has aged less than the one who stayed behind. Not by much. Just a fraction of a second. But it happened. Time itself moved differently for them. And today, you're going to understand exactly why. Time is not what you think it is. We imagine it like a river flowing steadily forward, the same for everyone, everywhere. 1 second on Earth equals 1 second on Mars, 1 second in deep space, 1 second everywhere in the universe, right? Wrong. Time is far stranger, far more flexible than we ever imagined. And the person who first realized this changed everything we thought we knew about reality itself. His name was Albert Einstein, and in 1905, he published a theory that would shake the foundations of physics. He called it special relativity. And buried within its equations was a truth so bizarre that even today, over a century later, it feels like magic. Time can slow down, time can speed up, and if you move fast enough, you can actually travel into the future. Here's how it works. Einstein realized that nothing in the universe can travel faster than light. Light moves at about 186,000 miles per second, and that speed is the ultimate cosmic speed limit. But here's the twist. As you approach that speed, time itself begins to behave strangely. The faster you move through space, the slower you move through time. It's not an illusion. It's not a trick. Your clock actually ticks slower. Your heart beats slower. Your cells age slower. From your perspective, everything feels normal. But compared to someone who's standing still, you're living in slow motion. Einstein called this time dilation, and it's one of the most mind-bending consequences of how our universe actually works. Now, you might be thinking, okay, that's interesting, but how does this apply to astronauts? They're not traveling anywhere near the speed of light. The International Space Station orbits Earth at about 17,500 miles per hour. That sounds incredibly fast, and it is by human standards. But compared to the speed of light, it's barely moving at all. So how could astronauts possibly experience time dilation? The answer lies in another part of Einstein's genius. A second theory he published in 1915 called general relativity, and this one has to do with gravity. Einstein discovered that gravity doesn't just pull objects together. It actually warps the fabric of space and time itself. Imagine a trampoline stretched tight. Now, place a heavy bowling ball in the center. The trampoline bends, creating a curve. That's what massive objects like planets and stars do to space-time. They bend it. And when space-time is bent by gravity, time runs differently. The stronger the gravity, the slower time moves. So someone standing at the bottom of a mountain, closer to Earth's core, experiences slightly stronger gravity than someone at the top. And because of that, time moves just a tiny bit slower for them. It's an impossibly small difference, but it's real, and it's measurable. Now here's where it gets exciting. Astronauts on the International Space Station are about 250 miles above Earth's surface. Up there, Earth's gravity is slightly weaker than it is down here. So according to general relativity, time should move faster for them. But wait, didn't we just say time moves slower when you're moving fast? Yes, and this is where things get beautifully complicated. Astronauts are experiencing two opposing effects at the same time. Their high speed causes time to slow down, thanks to special relativity. But their distance from Earth's gravity causes time to speed up, thanks to general relativity. So which one wins? It turns out the speed effect is stronger. Even though astronauts are farther from Earth's gravitational pull, they're moving so fast in orbit that the time dilation from their velocity outweighs the time dilation from weaker gravity. The result? Astronauts on the space station age slower than people on Earth. Not by much. After 6 months in space, an astronaut will have aged about 0.007 seconds, less than someone on the ground. It's a tiny, almost laughable difference. But it's real. It's been measured. It's been proven. And it's one of the most powerful confirmations we have that Einstein was right. Let's talk about the most famous example of this. Russian cosmonaut Sergei Krikalev holds the record for the most time spent in space. Over the course of his career, he spent 803 days orbiting Earth, and because of time dilation, he aged about 0.02 seconds, less than he would have if he'd stayed on the ground. That means Sergei Krikalev is the closest thing we have to a real-life time traveler. He's 0.02 seconds younger than he should be. He traveled into the future just a tiny bit, but he did it. And every astronaut who's ever gone to space has done the same thing. Now imagine if we could go faster. Much faster. If you could build a spaceship that travels at 90% the speed of light, and you flew around the universe for what feels like 1 year to you. When you came back to Earth, over 2 years would have passed here. Your friends would be older. Your family would have aged. But you'd barely have changed. Push it further. Travel at 99% the speed of light for 1 year, and when you return, 7 years will have passed on Earth. At 99.9%, 22 years. You could leave Earth as a 20-year-old, spend a single year traveling through space, and return to find yourself in a world where everyone you knew is middle-aged or elderly. You'd be a time traveler, not to the past, but to the future. And this isn't fantasy. This is physics. This is what the universe allows. Of course, we don't have the technology to travel anywhere near the speed of light. Not yet. But the fact that it's possible, the fact that time is not this rigid, unchanging thing, changes everything. It means time is personal. It's relative. It depends on where you are and how fast you're moving. Two people can experience time completely differently, and both of them are right. There is no universal clock ticking the same for everyone. Time is woven into the fabric of space itself, and when you move through space, you change how you move through time. And here's the truly humbling part. Every single thing we just talked about, every strange, reality-bending idea, has been tested and confirmed over and over again. Scientists use atomic clocks, the most precise time-keeping devices ever built, and they've measured time dilation in airplanes, in satellites, in particle accelerators. GPS satellites orbiting Earth have to account for time dilation, or they'd give you the wrong directions. The system wouldn't work without Einstein's equations. Your phone's navigation depends on the fact that time runs differently in space than it does on the ground. This isn't theory. This is the world we live in. This is reality. So the next time you look up at the night sky and see the International Space Station streak by like a fast-moving star, remember this. The people on board that tiny capsule are moving through time differently than you are. They're aging slower. They're living proof that time is not absolute. They're experiencing the universe in a way that's fundamentally different from ours. And one day, maybe in your lifetime, maybe in the next generation, we'll push this even further. We'll build ships that go faster. We'll send humans deeper into space. And when we do, time dilation won't be a fraction of a second. It'll be minutes, hours, maybe even years. We stand on the edge of something incredible, a future where the rules of time itself bend to human ambition. And understanding how it works, why it happens, is the first step in that journey. If this blew your mind, if you want to keep exploring the mysteries of space, time, and everything in between, hit that subscribe button right now. Join a community of curious minds who refuse to accept the world at face value, who want to dig deeper, to understand the universe as it really is. Because this is just the beginning. There are so many more secrets waiting to be uncovered, and I'll be here to guide you through every single one. Subscribe, turn on notifications, and let's keep exploring together. The universe is waiting.